Welcome to our class on probability. We're going to look at basic probabilities that will help us understand and tackle questions to do with probability. So to start with, I must mention that probability is wide. And being wide, you need to have a wider application practice of probability. Eventually, a question will be, which probability do I use when? And so I'll answer that question later. But for now, let me look at this tutorial sheet with a few questions that are here. So the probability, we have what we call conditional probability. We have what we call random variables. We also have what we call the probability distributions. So I'm going to start with what we call our random. So let me start with probabilities with contingency tables. So to start with, you need to understand that probability A is simply the probability of what? The event A happening over the total events that are possible. Probability of a complement of A is simply 1 minus the probability of A. Complement is to be without. So if A has 30%, without A is 70%. A is 60% or 0.6, without A is 0.4. You also need to know that probability A or B means what? We're uniting A union B. To unite is to add. A union B is equal to what? Probability of A plus probability of B minus the intersection of A and B. Okay, so the word O is the same word intersection, which means to add. If we're given A, given B, the words that you hear will be A assuming B, or A if B. All these mean what? Conditional probability. So you need to understand some grammar. Okay? O when B. So these ones all fall under what we call conditional probability, which falls under Bayes' theorem. A given B is simply equal to what? You bring the probability of B down there, and you intersect A, intersection B. I think that is what we're laboring throughout the week to understand. A given B, you bring the B down there, you intersect A and B. So A intersection B comes there. This is what we call what? Bayes' theorem. Now, probability with contingency table never misses. We have Fanta denoted by F. We have Coke denoted by C. We have a woman denoted by W and a man denoted by M. So I'm going to give you a hypothetical example here so that we go to the tutorial sheet. So if you're given figures as follows, want to see the gender that takes preferences of drinks. So we have gender here, and we have what? Gender will come here. Then we have the preference or the taste. So how many like Fanta? Maybe we have 7 here. All right. How many like from the men? Fanta, maybe we have 3. How many love Coke from the men? Maybe we have women, we have none who likes Coke. All right, then here we have maybe 10 men who love Coke. So get the totals. For the women, what is the total? 7. For the men, what's the total? 13. Fanta, the total 10. The total for Coke, it is 10. Then we can get the total of totals here, which is 20. So first thing you need to do, if you're not given the totals, tabulate the totals on your own. Then here we have total. All right. So let us find the probability of a Fanta. So I said probability of an event like Fanta F, you get the total for a Fanta. So Fanta, it's 10. 10 out of the total event, which is 20. We get 0.5. What is the probability of a woman being picked? Let's go to the women. The total for the women is what? 7 out of 20. What do we get? 0.35. Yes, there's a question.
Sorry. I just wanted to. There are some our colleagues whose videos are on. Maybe if they can be requested to just to turn them off. Since it's in the night, we may see things that.
All right, thank you so much. The consent, please deactivate your videos so that we don't. Yeah. So for the man, what is the probability of the man? Just go, the total for the man is what? 13 over 20, which is 0.65. Yes, Leah.
Sorry, it was a mistake.
Probability of Coke. The total for Coke is what? 10 over 20, which is 0.5. Any questions so far? So now the questions will now change slightly. They'll ask you now, find the probability that this person loves Fanta and is a woman. And means intersection. So Fanta, I'm trying to make it simple as can be. Intersection woman. So you go where they meet. Fanta and woman, they meet at what? 7. So 7 over 20 over the total, which is 0.35. So can somebody help me? What is the probability that somebody loves Coke and is a man? Coke and is a man.
1 over 20.
Coke intersection man, which is what? 10 over 20, which is 0.5. Correct. Now, suppose they ask you to say, find the probability that the person loves Fanta, given that it is a woman. You go where they meet, Fanta and a woman. All right, I'll do it in 2 ways. The shorter version, where they meet Fanta and a woman, they still meet at 7. But the total of a woman only. So you got a woman, the total of a woman, it is what? 7. So you're going to get
Okay.
a 1. If they swap it, suppose find the probability that of a woman given, they take Fanta. You go where they meet, woman and Fanta. They still meet at 7. But here the total for which one? At the bottom, the total for the Fanta. So you go here, the Fanta, what is our total? 10.
10.
So when you divide over 10 there, we get 0. What? 0.7. Okay. 0.7. So before I go any further, let's go to our tutorial sheet. We have this tutorial sheet here on probability, and we're given and we start with question 8. We have the data set of cars from a local dealership. So what they say, the first thing you do, you total up. Can you give me the totals?
The new 39.
Then 21 used.
Mm. 33. Then that is 27. 27.
Then what's the total of totals? So we've done the total of totals, the total this side, the total this side, the total here, and the total here. So this is 60, which must tally throughout. Now, please, let's answer based on what I've talked about. So, part 1, determine the probability that a randomly selected car is new. What are we looking for? probability nu, right? So who wants to help us to find the probability nu?
Okay. So I think that would be 39 over 60.
So we
Yes,
got nu 39 good over 60. What is our total? What is our answer?
That would be 0.65.
Correct. The next one, the ladies, find the probability that a randomly selected car is a sedan.
Going to be
21 over 60.
33 over 60.
Okay, so
Oh yeah,
for
33 over 60.
are we agreeing, ladies? Of a sedan, probability of a sedan?
33 over
Yes,
60.
33 over 60.
33 over 60, which is equal to what?
0.55.
0.55. Okay, we go to the gents now. Find the probability that a randomly selected car is new. So new and sedan. What does that mean?
It means 24 over 24
over 60.
So first, let's understand the grammar. New sedan is as good as it is new and it's a sedan. So the word "and" means what?
Intersection.
intersection.
Yes,
Intersection.
intersection. So a new sedan will be new intersection sedan. So
So-
whenever we're doing intersection, we're going to say where they meet new and
And 33.
so
And
where
sedan.
24 over what?
33.
If it's intersection, it is over the total. But if it's given, if there's a slash there, it will be divided by what is down here. Remember,
Okay.
intersection means
Yes.
for the grand total. But if there's a slash there, it's over the total, which is down here. Is that clear?
Yes.
All right. Maybe if you missed what I said, I want you to just follow the epitome of this whole thing that I did here. So remember I said female and woman, the same as female intersection woman. So I went to the female, the woman where they met, but the total here was over 20. But here I said female given woman, they still meet at 7. But the total for the woman, because the woman is down there, so this woman there is 7. So 7 over 7, which is 1. I can swap this one, woman given female. They meet at 7, but the total for what is down? The female was what? Down. So the total for the Fanta, was 10. So this is 7 over 10. Is that clear?
Yes.
All right. Now, if they said find the probability of female, find the probability of female or a Fanta or woman. Fanta or woman. Who remembers what the word "or" means?
Or is addition.
Okay, which is the same as what? The union, right?
1.
Can somebody expand this? Fanta union, woman. How do you expand this? Probability of F plus probability of what? Woman minus what?
Woman. Minus F intersection B or W. Sorry.
Very good. So our Fanta was 0.5. Our woman was what? 0.35. And our intersection was 0.35. So the final answer will be 0.5. Okay. Then there are conditions that you need to know under conditional probability. Number one, if A intersection what? If A intersection B is equal to 0, what does it mean? They are mutually exclusive. All right. That's what it means. A intersection B is equal to 0. It means they are mutually exclusive. If A intersection B is equal to probability of A times probability of B, it means they're independent. Or if you just say probability of A given B is equal to probability of A, it means they're independent. I repeat, these questions will come. They ask you, are these events mutually exclusive or independent? To be mutually exclusive means you have nothing in common. Your intersection of A and B is 0. So when you intersect, there's nothing common. They don't meet anywhere. This means they're mutually exclusive. If the intersection of A and B is equal to probability of A times probability of B, they're independent. Or if the probability of A given B, you maintain the top guy, it's still A. Or probability of B given A, maintain the top guy, it's still B. This means that these are what? Independent events. Events that are independent are events whose occurrences don't affect each other. So if we had A given B, it's still A. A given Z is still A. Whatever is down there doesn't affect the existence of the guy on top. Even here, B given A, whatever is down there doesn't affect the existence of the guy on top. Now I'm trying to prepare you for the test. This question might come in question, maybe the second or third. Contingency table always comes. So however it is twisted, I need you to get the concept. So this is where I want to rush to here. So easy does it. You need to take your time, learn a new concept every day, consolidate on it. So we're going to do 2 questions of this, then you understand what I'm talking about. So we're going to read as follows. The following table shows the total number of wins recorded by 2 friends playing tennis against each other based on the length of time they warmed up before the match. So I must also submit to you that English is a prerequisite for this course. You should have passed English to be in this class. So now part A or part 1 says, determine the probability that Deb wins the next match if she has a short warm-up. So we have warm-up time, short, long, and the total has been given. Okay, then we have Deb, Bob, and the total is there. You've seen the information that is there. I want us to apply the information I've been talking about. So in this instance here, I need us to learn how to make the notation. In short, find the probability that Deb wins, given if, assuming, so probably if we just put a slash there. So we're finding the probability of what? Deb if it is short. All right. So you can call this short S, long L, Deb D, Bob B. So we're looking for Deborah given short. Can somebody help us? What figures are we looking at? D given S. Let me start with the gents.
I think it's
Uh-huh.
probability of 4.
Where they meet at 4, correct?
Given 20.
Over 20. Gentlemen,
Yes.
you right? Are you agreeing?
Yes.
The gentlemen, are we
Four
agreeing?
over 10, yes.
Over 20, over 10?
Over
4
20.
over 10.
Over 10 is correct. Yes. This you redeemed the men. Why over 10? He's given a correct answer, but justify him. Why over 10?
We're looking at the data given. Deb, the wins, it's 4. Then the short warm up, the total is 10.
The total for the S, for the guy down here is 10.
Collins.
Correct.
Can I go ahead?
Uh-huh.
Yeah, so this is a condition of probability.
Uh-huh.
So what we should concentrate on is just the column. Is it the row? The row, the short row.
Uh-huh.
So we can't go and pick Bob because he's not included in the question. So like the other gentleman said, like wins 4, and then the total is, so we just concentrate on that row. Don't even need to pay attention to these others.
Okay. Correct. So key there is Bob if short time. So there are two things here. There's Deb and the short time. Where they're meeting, it is 4. This we are agreeing. But the question is this a total for Deb or the total for short? So you pick the total for the guy down here. So short, that's why we're getting the 10. Because the controversy would be, do we pick a 20 or pick a 10? Part 2, assuming Deb won the last match, determine the likelihood that the warm-up before the match was short. So how do you write the notation? This is conditional probability, but it is what? So assuming is the same word as if, so you put slash. If Deb, so slash Deb. Find what? Find short. So this is short given Deb. Where are they meeting? They're still meeting at 4. Are the total for which one? For short or for Deb? For Deb. So 20 there. So we're going to have 0.2 as the answer. So you need to have the grammar at your fingertips, assuming Deb, determine the probability that it will be a short one. So it's the reciprocal of this one here. So you need to really understand what's happening. Now, with that being said, I want somebody to intelligently give me the notation for part 3. Given that warm-up was short, determine the probability that Bob wins the next match. What do we write? Given that. So, the part given that, you just put a slash. Given that the warm-up was short, So given short, determine the probability that Bob wins the next match. So it's Bob given short. I've given you the notation. So what notation that we're going to have?
So can I, sorry to interrupt you. So the given one, when they say given, it's the one that's supposed to be down.
Yes.
Always.
Or assuming that, or if all these that are under these words go down.
Okay.
Yes.
Thank
So in short here, we're looking for the probability of what? Bob, given that it was short. So we've summed it up for us. Where you find given that, or assuming, or if, or when, just know that it goes down there. So given that the warm-up was short, find the probability that Bob wins the next match. So you find where they meet Bob and what? Short. They meet at 6. So 6 given the total for short is what? 10.
10.
So here we're going to have 0.6. So try part 4. Yes, Josh.
So the long one would be the one that is down. Then given that Bob wins, so it will be 24 over 40.
All right.
Can I also try? Okay. So we're looking at 4. So assuming that the warm-up was long, determine the probability that Bob wins the next match. So here we're going to say the probability intersection, or given that, well, probability over the probability of long, something like that.
So given long, correct. So slash long, the L come down there. Find what? Bob. So Bob comes on top.
Comes on top.
Yeah.
Okay. So what are we going to have here? Bob.
So there we have 24. Is it?
Correct.
Over 50. Over 40 or 50?
Over 40.
Over 40, okay. Okay.
Yes. So what do we have?
0.6.
0.6, correct. Then lastly, are the events Bob, Deb, and Long independent? Who remembers the rule for independence? So for Deb and Long to be independent, when you apply the probability for Deb and the probability for Long, they should give us an intersection. So probability of what? Deb times the probability of what? Long must be equal to what? The intersection. Deb intersection Long. That is the rule. All right, so what's the probability of Deb? 20 over 50. All right, which is 0.4. What's the probability for Long?
40 over 50.
40 over 50, which is what? 0.8.
0.8.
The total is what when you apply these two?
0.32.
0.32, correct. This one must be equal to what? Deb intersection.
0.32.
So what is Deb long? 16 over what?
16 over 50.
Good. 16 over 50, which is what?
0.32.
0.32. Are they the same? Yes.
Yes, everything.
What is the conclusion? Are they independent? Yes, they're independent. Yes, they're independent. A quick, can you remember, how do we know events are independent? They're independent if the intersection A intersection B is equal to the probability of the individuals A times B. That's what we know. How do we know they're mutually exclusive? If the intersection is 0. Okay. So that was our recap, unless there are any questions. So we can.
So, Mr. Collins, could you kindly explain the last question, the Deb and Long one? I think I'm a bit lost on that one.
If they're independent?
Yes.
All right.
I know you said for us to know that they are independent, the events of the two needs to be the same, isn't it?
No, and means multiplying, all right? So
yes.
If probabilities Deb and Long are supposed to be independent, multiply them to find whether they will give you an intersection. So to start with, find the probability of Deb alone, find the probability of Long alone. So we found the probability of Deb, which was 20 over 50, it gave us 0.4. Probability of Long alone, it was what? 40 over 50, which was 0.8. Then multiply them. When you multiply them, they give us 0.32. Then find the intersection of Deb and Long now using this table. How do you find intersection of Deb and Long? You see where they meet, Deb and Long, they meet at 16 over the grand total, which is 50. If the answer that we got when we multiply them is the same as the answer that we are getting now, then just know that these two are what? They are independent.